definitely the harder day of this because the numbers got funky. So you really had to understand what you were doing. Okay, so it said circle the numbers that are equivalent to a 1/5%. And I think this kind of helped. I used this with some of my later classes yesterday. And I said, okay, I want you to imagine that you have from here to here is 100%. Okay, that is, you got every single point on a test. You got 100%. Okay, 1/5 of a percent would be like, this would be 1%. And it's even less than that. It's 1/5 of that. Does that make sense how incredibly small that is? It is less than 1 whole. Okay, so when you write this as a decimal, okay, this would be 0.2%. 0.2%, not even 1 whole percent. Okay, it'd be like 20 cents out of $1 is how much that is. Okay, so we're trying to figure out which ones are equivalent. So can you tell me which one is not equivalent? Lily, 20%. Yeah, there's no way. 20% is not the same as 0.2%, so it does not work. Okay, is there another one that does not work? 2 out of 100. How much is 2 out of 100? 2%, because anything out of 100, that's a percent. So 2% is not the same as 0.2%. Okay, is there another one that you know is not correct? How much percent would this be? 20. That would be 20%. So no, that's not it. Okay, so if I take this 0.2 and I move the decimal point 2 times like I'm supposed to, I get this number. Remember that when we're working with percentages, like if this is 30%, if I want to change that to a decimal, I move it 2 times and get 0.3. This is the exact same thing. I still move it 2 times and I get 0.002. Okay, questions on that one? All right, so you had to be able to do that in order to do questions like number 2. So it says, what is 1/8 of a percent of 800? Should this answer be very big? What is 1% of 800? What is 1% of 800? 8. 1% of 800 is 8. So what would 0.5% of 800 be? 4. And what is this? An 8. So it's going to be less than 4. Is your answer less than 4? Yes. Okay, so then that means you're probably on the right track if it's less than that. All right, so let's set this one up. All right, this is out of 800, so that is my total, right? So I have my part equals percent times whole. We just decided 800 is my whole. I do know my percent, so I'm going to have to change 1/8 into a decimal. What is 1/8 as a decimal? Isn't it hold on, isn't it 125%? This is the same? Then I have to move the decimal 2 times. Okay, so then I move the decimal 2 times. 1, 2. So the number I put in here is 0.00125. And then I am looking for the part. So all I have to do is make sure I put in this correct number and then times it by 800. So what do you get when you take that number and times it by 800? 1. Just 1? That's it? Okay. So that means my part is 1. And our estimate was that it was less than 4. And 1 is less than 4, so that's good. Questions on that one before I keep going? All right, next one. 3 is what percent of 1,200? Okay, so let's look at this one. All right, here's my out of 1,200, so that goes in for my whole. Here is my part, because this would be the equals. So 3 equals, we're looking for the percent times the whole amount is 1,200. So if I make this look like an algebra equation, I write it pretty, and I write it like this. And then I divide both sides by 1,200. So divide this by 1,200, divide this by 1,200. Okay, what is 3 divided by 1,200? How much is it? Less than that. 3 divided by 1,200. 3 divided by 1,200 would be 0.0025, right? Okay. All right, so 0.0025. Now, is that in percent? No, that's in decimal mode. So what do I have to do? Move your decimal 2 times. Good. So bingo, bango. So my answer is 0.25%. It means it's a 1/4 of a percent. You could write it either way. It's a fourth of a percent. Because if you think about that, if you had a test that was worth 1,200, but let's say a class, let's say there were 1,200 points in your class, and you only got 3 points all semester, did you do very well? No, you stink. Okay, 3 out of 1,200 would be very little. So your percentage would be a fourth of a percent. All right, next one, 19.5 is 0.75% of what? What am I missing here? You're missing the whole because it's out of what? Lily, do you have a question?
Yeah.
I would think they would, but you have to read, you know how they always type it in blue? They're probably going to tell you what form, so I would look to see what form they're asking for. Okay, so we have 19.5 equals, so 19.5 equals 0.75%. What do I have to put into my equation? A decimal. So what decimal is that going to be?
0.007.
There you go, because you have to move it 2 times. And we're looking for the whole. So I just have to divide both sides by 0.0075. All right, and what is 19.5 divided by 0.0075? 2,600. Okay, now let's see, does that make sense? Okay, if I got 19 points and I got less than 0.5%, is it going to be a pretty big number?
Yes.
Yeah, that's going to be a big number. All right, number 3, the unemployment rate falls 0.4% out of 3,500 employed workers. How many people find jobs? Okay, so we got to know what is the percent, which we know, and we got to decide, is that the part or the whole? That's a whole, because it says out of 35 unemployed workers. So that is the whole amount right there. So we're just going to plug that in. We're looking for the part. And we've got 0.4, but we have to change it. So bingo, bango, 0.004 times 3,500. Okay, so if you take 0.004 times 3,500, what do you get? 14. So 14 was this workers, 14 people. You think that's very good? Only 14 people. Yeah, if you have 3,500 people and only 14 get jobs. Oh, the answer's good, yes, but that's not very good in real life, right? Like that would not be very many people. Okay, any questions on what we did yesterday? Nope. All right, let's go ahead and look at what we're going to do today. All right, today we're going to understand how to calculate percent error. Okay, which is really not that bad. All right, so on this slide right here, I wanted to put in there what digits want you to do, but I'm going to tell you something slightly different, okay? So this has this poor sad soul getting on a bus. Dude, look how sad she looks. I was like, I don't know why she could have been a happy person. Okay, and she's saying, so I guess there's 36 passengers on the bus, okay? That's her estimate, right? But then somebody actually counted, and there was actually 45 people on the bus. So she was off, right? She was off by quite a few. All right, so what you're going to do is to find the percent error. You're always going to find the difference, okay? So here's the measured or estimated, take away the actual. So we're taking 45, take away 36. You're finding the difference, okay? So this is how I see it. You're going to find the difference, okay? And you're always going to put the difference over the actual or the original. So we're going to put actual, parentheses, original. Okay, so doing this my way, if I say what is the difference between what she thought and how many people were on the bus, you would say the difference is 9. She thought there were 36, there were actually 45. The difference is 9. Okay, over the actual amount, how many were actually on the bus? 45. And do I know how to change that to a percentage? You just divide, yeah. So 9 divided by 45. So if I do 9 divided by 45, I get 0.2. Do I know how to change 0.2 into a percent? Just move the decimal point 2 times. Okay, and that's how they get this answer, 20%. Okay, so that means she was off by 20%. Is that very good? I wouldn't want to be off by 20%, right? That's quite a bit. So she was off by a lot, probably because she's oh so sad. All right, let's look at this one. Okay, find the percent error of each statement value to the nearest whole percent. We always want to make sure that whatever digits tells us to round to, that we round to that, otherwise we get it wrong. Okay, so let's look at the first one. Let's look at column A. Okay, so the estimated value was 40. The actual value is 45. So what was the first thing I told you to find? The difference. What's the difference? 5. Okay, and then I said to always put that over what? The actual or the original, and the actual is 45. So 5 out of 45. And we can divide that, right? 5 divided by 45. And I get that number. So what percent is that rounded to the nearest whole? 11%. Because you move your decimal point 2 times. And then this one is not going to change that to a 12, right? That one's going to keep that at an 11. So this would be 11%. That's the percent of error. In science, have you guys talked about percent of error at all? Science. This is a huge science thing. That's where you would use this probably the most. All right, let's look at the next one. So the next one, what was I supposed to do again? The difference. So what's the difference between 63 and 75? 12. Yeah, wouldn't this be 63 to 70 would be 7 plus another 5? So 7 and 5 would be 12. Okay. Over what? 75. Over 75. So 12 divided by 75. And I get 0.16. So what percent would that be? 16%. Very good. All right, I would like you to try this next one on your own and see what you get there. What? That's why I'm asking you to always find the difference, because that's just like absolute value, which is what they were saying here. See, the absolute value would still be positive 9. That's why I say just find the difference. All right, go ahead and do that last one. Okay, any questions on that? Nope? Okay, good. All right. All right, next one. So this one says, anyone who guesses within 5% of the actual number of jelly beans in the jar is a winner. Did you guys ever do this in elementary school? Yeah? I remember back to my elementary school. They had like a big jar, and if you guessed how much candy was in it, then you won the jar. Okay, so suppose there are 486 jelly beans in the jar. Who wins? Okay, so kind of our question is, what is 5% of each of those numbers? Does that make sense? And isn't that what we've just been doing on all the previous days? Okay, how could I find 5% of Javier's number? How could I find 5%? Okay, because that would be the original versus, okay, I could totally do that. Anybody else want to find another? That's one strategy, totally workable. Any other thoughts? That means I'd have to work 4 problems, right? Which would be okay. What do you mean by adding? Okay, well, let's start there then, and let's see. Okay, so what is the difference between the actual and Javier's number? 15. Okay, so 15 out of how many? 486. Okay, so tell me what percent that is. It's 3%. You already did it? You're passed. Okay, 3%. So would Javier win? What does he have to be within? 5%. Okay, so Javier would be a winner. All right, so let's just split this up into rows. So these 2 rows right here, these first 2, I want you guys to do Sarah's. I want these 2 rows right here to do Lisa's, and I want the last 2 rows to do Jay. Questions on that then? Everybody get that okay? All right. All right, So practice